Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video number 17, redshifts and dark energy. The viscosity of the background takes energy from the meons and thus the loops. The effect on a photon is frequency-independent tired light, which is not something which is currently considered to be part of the redshift of cosmological objects. Currently, the interpretation of redshift observations is that space is expanding and the rate of expansion of the universe is increasing. However, since the meon sizes do not change, and they are the basic constituents of the only universe, there can be no expansion of space. In the hypothesis outlined here, the alternative interpretation that emerges is that the tired light redshift effect exceeds that of the Hubble constant. The redshifts within the envelope of our Big Bang are the net effect of a larger tired light redshift versus a smaller blue shift from our contracting Big Bang. In this model, no object has a relative velocity above light speed. The expansion of space is a misinterpretation of the redshift effect of tired light over distance, and so there is no need for dark energy and no acceleration of the Hubble constant. The existence of failed Big Bangs within our own contracting Big Bang envelope can be tested through observation and reinterpretation, since this has not been considered before. New Big Bangs do not mean new universes, however. Each Big Bang will have its own inflation rates and loop symmetries. Our matter has 3 pairs in a loop, so threefold symmetry. Those failed, failing, or new Big Bangs may have 3-pair number loops, but will have different inflation rates, and so different loop sizes or masses, which will complicate redshift interpretation because their photon absorption and emission spectra, due to their equivalent atomic loop stacks, will be shifted, just as if their sources were at different distances or relative velocities. Regardless of the relative loop sizes of other Big Bangs, they will all have the same physical laws, but the different loop masses will generate different chemistry. Some objects beyond our Big Bang could look like early galaxies if they're newly formed, but will have large redshift because of frequency-independent tired light effect over their massive distances from us. However, most external galaxies will probably be older than our Big Bang and will have massive redshifts. The redshifts we observe are of objects that could be within our own Big Bang envelope and are components of it, or components of other Big Bangs overlapping, or objects outside our own Big Bang envelope. The existence of celestial objects that appear to be conjoined, but which have different redshifts, is one example of how to identify to which group objects belong. An object within our envelope and part of our Big Bang will have a lower redshift than an object at the same distance from us that is part of another Big Bang, unless that other Big Bang produced loop sizes significantly different to our own loops, or its velocity in our direction is high. This is because of the relative sizes of the tired light viscosity redshift rate compared with our Big Bang contraction, if there is no net velocity due to the other Big Bang and it has similar sized loops. Objects beyond our bigger envelope will generally have such large tired-light viscosity redshifts that these will outweigh almost any relative velocity redshift. In this hypothesis, there are no relative velocities above light speed. Related videos will be 14, why the redshift of tired light is frequency independent, and 30, relativity and thermodynamics. Thank you for watching.